Welcome to Los Angeles Data Platform. Today we have a session Back to the Future with Temporal Tables by Randolph West. One small announcement is we'll have SQL Server in Los Angeles, or as we call it now, Data SQL Server in Los Angeles. It's going to be June 12th, which is basically less than 30 days. You can, if you see my screen, you can click on the links to see the sessions or to RSVP, or just go to our website. And it's for people that never attended SQL Server event. It's just like a user group, except it's not 2-3 hours. It's a full day, and it's not one speaker. It's in our case, it's going to be total of 30 speakers. Different topics you can choose, and it's all going to be remote. So you can stay on your couch and enjoy sessions from people. You don't have to listen for the full day. If you just want to jump in for a few sessions, you can do it as well. I think I'm done with my bumbling and rumbling. Randolph, it's all yours. Thank you for presenting today.
You're welcome. You can just kick things off here. So, if I've done this correctly, you should see my screen.
Yes.
And I'm just going to minimize this little beast. There we go. So, Steven Spielberg presents Wednesday, May 19, 2021. Where we're going, we don't need a DeLorean because it's temporal tables. Back to the future with temporal tables. This is me, Randolph West, for the LA Data Platform. Hi, everyone. Thank you for joining me this evening, or this morning, or tomorrow morning if you're Steve. This is me. Everybody has an About Me slide. This is mine. You may know me from Twitter. You may know me from being a co-author in a number of books that you can see on the right there. I am an MVP. I'm also on the advisory board of the Azure Data Community, which is a new initiative from Microsoft to help out user groups. And I am on the organizing committee for Data Saturdays. I have a company called Born SQL that where you can go and visit on my website. I write a blog every week. I also have the most important thing on the slide right in the middle. That is my email address. So if you have any questions about the slides or the demos today, or you have any questions about SQL Server that relate to what we've discussed this evening, please email me. And you will have to mention in the email where you got my address from, because I'm quite hardcore about people emailing me. But if you just mention that you saw my session today, or you're watching the video later and you have a question, please feel free to send me an email and I will respond. And if I don't know the answer, I will find out who can answer it and direct you accordingly. So let's talk about system version temporal tables, or temporal tables, depending on where you're from in the world. It says system version because that's exactly what it is. Inside SQL Server's database engine, since 2016, you can create something called a temporal table, and it keeps track of the effective dates internally. So you don't have to do anything when you're modifying data to tell the system how to do it. It does it for you. System version temporal tables, or just temporal tables, keep a full history of data changes. Now, I put the word data in there. Microsoft's documentation will tell you a couple of things, some of which are marketing. And we'll get to marketing because Microsoft is a marketing company, it's a legal firm, and it writes software. So some of the things that you will read about temporal tables, it does have limitations. It may not be exactly what Microsoft tells you, and that's what we're going to talk about today. I think temporal tables are an extremely valuable feature in the product, but there are limitations. There are some things that you have to know about before implementing them. So it keeps a full history of data changes, and it allows easy point-in-time analysis. So if you want to go and figure out what your data looked like at a certain point in time, you run a specific type of select query, which we'll get into in the demonstration later, and you can see exactly how the data looked at that moment in time. This is where the system versioning comes in. The period of validity for each row is managed by the database engine. You don't have to do anything. All you have to do is set up the temporal table, and it will manage everything for you as mentioned. To implement temporal tables, you need 2 period columns, a from date and time and a to date and time, because you need to have a valid period of a start and an end date and time. It has to be a date time to data type, or they have to be date time to data types. But the cool thing is date time 2 has various sizes. You can have a different size option. You may want your granularity to be 0 seconds, or you can have it up to 100 nanoseconds. Date time 2 has the option in brackets where you can choose 0 through 7. You can choose any of those depending on what granularity you want. As I mentioned before, it records the validity period per row. So if you're updating a whole bunch of rows at the same time, it'll update all of those for you on each row. And whenever a row is modified. Now, as you know, when you modify a row, that means an update or a delete. Inserts are not a modification, it's new data, and reading obviously isn't a modification either. So whenever you do an update or a delete, it may remove the row from the table, but it's keeping a copy of that in the history table, and we'll talk about that. In fact, on the next slide, it references a history table. The history table has a mirrored schema, which means that the column data types are the same because it has to be able to keep a full record of exactly what you've got in your main table. It stores the previous version of the row. If you decide to update the row 1,000,000 times in an hour, it will keep 1,000,000 copies of the previous version of the row as it updates. So that does have storage and performance implications. I'll put it that way. And again, whenever a row is modified, that's what happens. So history tables, which store the history, because Microsoft's good at naming things, the history table can be created manually by yourself or by the database engine when you create your temporal table. So I'll show you in the demo as well. When you create the table, you can say, I want a temporal table. These are my 2 period columns, and it'll automatically create the history table. Or if you want to manage how the storage is allocated for your history table, you can create your table manually, set up the storage steps and file groups and all of that kind of stuff, and then link it to your current table. So the question would be, why would you want to use temporal tables instead of manual auditing or triggers or some other technique for keeping track of what's changed in your database? Remember I said that Microsoft will do a little bit of marketing. This is one of those cases where this is a marketing slide. They say that you can audit all data changes and perform data forensics when necessary. Unfortunately, the term forensics has a specific meaning in legal terms, and that has a requirement of a chain of custody. In other words, you have to be able to guarantee that what you're seeing in the history is exactly what happened. Temporal tables don't do that. I'll show you how and why, but for the purposes of this slide, data forensics is not possible if you expect a full chain of custody for what happened to your data. I'll show you in the demos as well. But basically, if you drop a column in your main table, it will drop the column in the history table with no warning, as long as you have the right permissions to do so. And unless you have auditing set up separately, you will not be notified of that change. So that's why I say this is a marketing slide, because data forensics isn't what you think it is. It does audit all the data changes, but if you modify the structure of the table in any way, it doesn't necessarily keep track of that change. But why I think temporal is very cool is that you can reconstruct the state of data at any time in the past, provided it's in the history. So one of the killer features for me is, I'll get to that. So you can reconstruct the state of data at any time in the past. So one of the things that this is useful for is if you're doing reporting. So you might want to compare this quarter's data with the previous year's quarter of the same time, year-on-year comparisons. You can just run a select statement with specifying the history period, and it will return the data exactly as it was. You don't have to go through aggregation and all that kind of stuff and through the data warehouse to see what the data was at that time, because it's in the history table already. You can also do a better job of maintaining slowly changing dimensions. So if you're doing data warehousing or some other kind of BI, when you have a slowly changing dimension, there is a possibility in your data warehouse where a change to your dimension can cause older data to break, because the relationship between your dimension and your facts data is broken. But because you are keeping track of the history of that dimension in a temporal table, you can write your select query that does the fact and dimension link using one of the temporal select queries. And this is the killer feature for me. You can recover from accidental data loss or changes and application errors almost immediately. Because if you know when something went wrong, you can go back running a simple select query against the temporal table and see exactly what the data looked like before that change, provided it wasn't a column change. If you dropped a column, well, good luck, you're going to have to go to your backups. But if you accidentally ran an update without a where clause or deleted stuff from the table, then you can go into your temporal history and re-import that stuff straight away. And it's much quicker than doing a recovery or a restore from backup.
Good question. What about truncate? If somebody does truncate by mistake?
Excellent question. You cannot truncate a temporal table while system versioning is enabled. I have an example of that in the demo, but thank you for asking. Very good question. So as I mentioned in the little tag at the bottom there, recovery from accidental data loss or change is the killer feature for me. And now we're going to talk a little bit about some of those caveats. So before we get into the caveats, let's talk a little bit about application support. If you've got a vendor supplied application and you're not allowed to make changes to the tables, maybe you can make indexes and stuff like that, but they really don't like it if you make changes to the code. What you can do is add temporal support to the tables and hide the 2 period columns. Now, this hidden period column setting only applies to period columns. You cannot do this to other columns because that's just not supported by Microsoft. There's no way to do that. There's no official way to do that. But if you want to have application support for a vendor application and use temporal tables as well, you can do it as long as you set the columns as hidden. And I'll show you how to do that in the demos as well. Let's talk about some of the limits, considerations, caveats. I did mention performance before, but there's a couple of other things as well. In your main table, your current table, your temporal table, you have to have a primary key because you have to have a way of uniquely identifying every row in the table. That makes sense. You cannot have a primary key in the history table because you will have multiple copies of the same row that has the same primary key with 1 or 2 minor changes. And in fact, you're not allowed to have any constraints in the history table because it's just a record of the changes. If you need to query that data and you want to do some sort of relationship to another table, you will also have to make sure that the other table has temporal history as well and go through the 2 main tables if you want to do a join that way. So there is a limit to what you can do when you're joining tables. You can join your main table, but you cannot do foreign key constraints, you cannot do check constraints, you cannot do default constraints in the history table. You can still do it in the current table. This one seems obvious on the face of it, but the history table must be stored in the same database as the current table. If you have, for example, an auditing process which uses XML path for XML path type of queries, so you have a trigger or a store procedure that writes the change to XML and then goes and puts it into a different database, you have to rethink that if you're going to store your temporal data, history data in your current database, because it's going to use space. There are some ways around that, but you have to understand that your history table will be in the same database as your current table. To make up for the fact that it uses up more space, they by default use page compression on the history table. When you set it up, it is by default set to page compression. If you want to do some other stuff like column store compression, you would have to do that independently of setting up the history table. This one might be a bit of a problem for you if you have partitioned tables and you want to employ temporal tables on your partition table. Let's say that you have 10 partitions and you want to put temporal data, you want to put the primary partition, the current partition of the current data, and have temporal support for that. You have to also understand that the history table will be in the default file group. Now you can, I haven't tried this, but I imagine that if you set up your history table independently and then connect it to your current table, you might be able to get around that, but I haven't tried that. But as far as the official documentation is concerned, if you want to set up a temporal table for a partition table, it will store that in the default file group. This is one for those of you who are worried about performance. Because of the way the temporal table functionality works, it takes the existing row, and even if you're only changing a bit column or an integer column in that row, it takes the entire row and writes it off to the history. So if you've got a content management system or you're storing images or Word documents or something, imagine a type of SharePoint environment where you've got your documents embedded in the columns using var binary, for example, or you have lots of text. It's going to have to write that entire row away to the history table, and then it's going to do page compression. So there is a performance impact if you have large off-row data in your current table. And it says significant, this is in the documentation, it is significant performance and storage costs. You have to keep in mind that if you're storing large columns, you are going to have to make sure that they don't take up too much space in the history, so you might have to do some manual cleaning up every now and then in your maintenance plan.
I can assume that XML is going to have the same problem, right?
That is correct, because it's also the same type of issue. You've got up to 2 gigabytes per column per row, yeah.
Thank you.
This was the question that you asked earlier, Steve. Truncate table is not supported while system versioning is on. That doesn't mean that it's not supported at all. If you turn off system versioning, in other words, if you turn off the link between your current table and your history table, then yes, you can truncate both tables if you have the right permissions. But while it's enabled, while it's storing that history, you cannot truncate your table, and that's for safety. Additionally, you cannot do direct modification of the history data while system versioning is enabled. But if you break that link, if you have the right permissions to do so, then you can do whatever you like to the history data as well, which again goes back to that point about the chain of custody not being completely accurate. If you want to read more about temporal tables and their limits and other considerations, you can look at the URL there. You can also use your favorite search engine and it'll come up. Again, Microsoft's good at naming things, especially the documentation pages. It's very easy to find this stuff. So let's talk a little bit about managing that history, because if you have a large amount of data that gets updated frequently, or if you have nvarchar max columns that are updated periodically and it's taking up a lot of space in your history table, you need to clean that up. If you're using temporal tables in 2016, you have to do it manually, unless you have a couple of the options that are available. But in 2017 and 2019, and in Azure SQL Database, there's a few more options available to you. Okay, I don't see the chat, but I'd like to hear if anybody has ever used Stretch Database ever, not even in production, just any use of Stretch Database.
Heard about it from Armando 5 years ago.
Heard about it, yeah. Once. Yeah, not even once. That sounded like Chris. Yeah. This is where an idea that seemed good on paper was implemented poorly, in that stretch database, when it was first introduced, was quite inexpensive. It had a lot of limitations, but those limitations were fine given the price that they were asking at the time. Unfortunately, when it was released as, what do they call it? I don't know, RTM. When it was released to the general GA, they call it GA now, general availability. When it became generally available, they added on a component of compute cost as well. In other words, whenever you wanted to use stretch database, you would have to pay for the CPU power as well as the storage. So it became too expensive for what it gives you. The idea was to have online archives of massive amounts of data. And storage is cheap in the cloud if you're using plain old Azure blob storage. It's really, really inexpensive compared to stuff on site. So it was a good idea, but unfortunately, I think they bungled the pricing of that. So I don't know anybody who's ever used this in production. But for completeness, it is available to you if you want to manage your historical data retention in temporal tables. It's good to know that it's there. You can also use table partitioning of your history table. So we're not talking about table partitioning of the current table. We're talking about going into your history table and paging, or what's it called, switching partitions in and out and archiving the old partitions in a different file group. So you can do that. There's nothing stopping you from doing that. If you've got a window of, let's say, the last 3 months, and you have a maintenance plan that moves that data out every month, you just add this into that process, and that's how you would manage that. And that's a pretty cool feature if you're up to the challenge. You can also, as I mentioned, on 2016 specifically, custom cleanup. So you can, every maintenance window, you can go in and run a script. You have to break the connection between the current table and the history table, and go into a cleanup script which deletes some of the older rows. Or you can truncate it if you like, but you would have to write something yourself to do that. And then on 2017 and 2019, as well as Azure SQL Database, you can implement something called a retention policy. Now, the retention policy is counted in weeks and months. So you can set the retention policy of, let's say, 9 months, and that means your history will keep the latest 9 months of your data. And when it comes to that point in time, there's a background task that periodically cleans up those rows when the database isn't too busy. So you may see data in your history that is a little bit older than the retention policy allows, but it will eventually get there and clean it up that way. I think the retention policy is was the only new feature added to temporal tables in 2017, but it's a very welcome one, especially with the lack of stretch database, or the cost of stretch database. And if you want to read more about managing retention of historical data, you can look at that link in your own time. And in my demo, I also go into a little bit of that. Now, seeing as we've had some interaction from the audience, and I welcome interaction from the audience, I'd also like to know how many of you folks have used memory optimized tables at all. Never mind temporal tables, but memory optimized tables. That would be what was previously known as Hekaton.
I have one production application that uses memory optimized tables for small, low volume, like lookup tables.
That is a very good use case for memory optimized tables. The main challenge with these is the memory requirement is 4 times the storage. So if you have a table that is 10 gigabytes and you want to memory optimize it, you need 40 gigs of space. Plus, on standard edition, and I know not everybody uses enterprise edition, and that's just a function of price, you have a maximum of 32 gigabytes available to you on standard edition for memory optimized tables. So you have to divide that by 4 to see if it's useful to you. Additionally, if you want to translate between in memory and on disk, because there's still that need to have some sort of transaction log going, that translation between in-memory and on disk is quite expensive. And as it turns out, the current table in temporal tables, if you're using memory optimized temporal tables, is stored in memory, as you'd expect, but the history table is stored on disk. It makes sense because your history table has to be persisted somewhere, and your in-memory stuff is transient, if you like. And it also has an internal staging table because it has to take whatever's in the current table and translate it into something that can be persisted to the history table. Because in-memory objects are stored differently using pointers and stuff, it doesn't have the same data structure as the on-disk stuff. So there has to be some sort of translation, and that is expensive. But it works in standard edition if your table is small enough. I like memory optimized tables, not talking about temporal tables here, but I like memory optimized tables for session state. So if you want to keep track of who's logged into your system, the lookup tables was an excellent example as well. You've got small amounts of data that need to be accessed frequently, then you would use memory optimized tables. And with SQL Server 2019, your tempdb metadata can also be put into memory optimized structures as well. So if you're creating a lot of temp tables, that's something to consider. And that's unrelated to temporal tables, but I think is a cool feature to know about. So this is my favorite part of the entire session. How does temporal table system version temporal tables work? How does it all work? And the answer is you've got a table and you've got history. Simple. Thank you for coming to my TED Talk. So let's do the demos, because that's what you came here for. I mean, I could tell you all these wonderful things about it, and now we're going to have a look at how it all works. So I'm going to slide over to Management Studio, and hopefully you can see my screen. Shout out to say yes or no.
Yes.
Excellent. Now, because I use this computer for a lot of things that are not just demos for my favorite people in California, I have got a filter up here of my database list, but rest assured that the filter is set to show temporal demo. And that's what we're going to do now. I am going to show you the version that I'm running here and drop the database if it exists. So let me just run that now. And there you go. I'm running SQL Server 2019 CU8. It was released in November, so I haven't updated this for a while. And it's the Developer Edition. Now, if you don't know this already, Developer Edition is exactly the same functionality as Enterprise Edition. There is no feature flag, if you like, in Developer Edition to turn off enterprise features. I just wanted to make that clear for you now. So if you're going to be testing this on Standard Edition so that you can deploy it on your site, be aware that any time you do stuff like in-memory or other related stuff, you're going to see different things. So you have to test it properly. I just wanted to make that clear up front, that because I'm using Developer Edition, it's the same as Enterprise. So what are we going to do here? We are going to create a plain old database. Create database temporal demo. It is going to take whatever's in my model database and create a new database called temporal demo. And then we're going to use that. Very, very straightforward. And if we go over here on the left, there's my database. And it is empty, as you'd expect. Cool. There's nothing exciting or difficult here so far. And please, if you need me to make the text bigger, just let me know. But the first thing we're going to do is we're going to create a new temporal table without specifying the history table. If you remember back to the slides, this is the default way to do stuff. And you'll see that this is fairly close to how you would normally create a table, but there are some extra features that we're going to talk about. And if I've done this correctly, Control-1 should zoom in. So let's see what happens. Hey, it worked. So we're going to create a table with a primary key on employee ID, which is an integer. It's an identity, so it'll auto increment. We've got a name, which is nvarchar 100, position, department, address, annual salary, which I will point out as decimal 10,2. If you're storing financial information, please don't use a floating point data type. If you're going to store anything to do with money, store it in a decimal. This is not the best kind of decimal to store because it's only got 2 decimal places, because if you want to do math, it's going to round. But please don't use floating point like double or float and real, I think it's called in SQL Server. See, I don't even know what the columns are called, even though I've written books about SQL Server, because I never used them. You only need to use... Yeah, go ahead.
Go ahead. What about money?
That is an excellent question. Thank you for asking. For those of you who don't know, money and small money are 2 data types that exist in SQL Server that are, I refer to them as convenient shorthand for using the decimal data types. But what you need to know is that it doesn't store the data on disk the same way the decimal does. In fact, the money data type, as opposed to small money, stores data in exactly the same format as big int. And small money stores data on the disk surface the exact same way as int. So it's easy to do a lot of math on them. So if you're going to do calculations, then money and small money are great for that because it's very well optimized, but you need to take rounding into consideration. So if you're going to do a lot of math on your data, like multiplying or dividing financial values, be aware that you would have to make sure you're storing enough decimal places to make it less problematic. Or, yeah, you don't want it to round up too badly because then it'll cause problems with your calculations. But it's a very good question. You can use money, you can use small money, just be aware of the limitations. If all you're doing is storing it, go right ahead. It's still storing it as on disk like a big int would, and the decimal points are automatically calculated. You get 4 with money. Great question. So here we've got our annual salary, and then we've got the 2 period columns. Now, if you remember the slides, I said that they have to be of type datetime2. The granularity is up to you. I like to use datetime2.3 because it is a drop-in replacement for datetime. Because if you know your data types, datetime has millisecond accuracy, except it's not millisecond accurate, it is 3 millisecond accurate. So I like datetime2 with 3 because it stores up to 3 digits, which is milliseconds, and it uses 1 less byte per column per row than datetime. Datetime uses 8 by default. Datetime2.3 uses 7 bytes. So that's a cool convenience if you're thinking about data types, of saving yourself 1 byte per column per row by using datetime2.3 instead of datetime. You can call these period columns whatever you like. I've called it valid from and valid to because that's just my naming convention, but you can, if you look at the documentation, they'll call it sys time start or sys time end or something like that. It doesn't matter what they're called as long as you know what it is. And the reason it doesn't matter what you call it is because here's where you specify which one is the starting point and which one's the ending point. So for every single row in your table, that row will have a validity. It'll have the time that the row was valid from and a time that the row was valid to. Notice that neither of them says null. So there is a magic string or a magic value that is used for stuff that is still valid into the future. And I'll show you that. So we're saying here, my 2 period columns are valid from and valid to. They're of that type, generated always, in other words, system generated, as the row start and as the row end. And then this is the magic that connects it to a history table. Over here, the system versioning is what connects it to a history table. This period 4 is an ANSI standard, SQL ANSI standard that says we're creating a temporal table. And we're going to use these 2 columns as the from and to dates. So let's just run this and see what happens. And with much fanfare, it's very, very boring. We're going to go over here. We're going to say refresh. We're going to look at our tables. And sure enough, there is our table. You'll notice that it has an icon that looks like a little clock because the current table, the one that we created, dbo.employee, is the system version table. And then because SQL Server was asked to automatically create the history table, it gave it a name of dbo.msql _ temporal history 4, and then the object ID. So if you look at sys.tables, that 5815 will be the same object ID as my dbo.employee. Very, very simple. If we expand this out, you will see that the columns almost match exactly. So let me scroll up a little there. The only difference is that if I had any constraints on my current table, which is the columns at the bottom, you would see those there, but not in the ones at the top. And also you'll see that my primary key, employee ID, isn't a primary key in the temporal history table. Very, very straightforward, I think. So we've looked at it in the Object Explorer. Now let's right-click on temporal history and go and look at the properties, because here I'm going to show you that it is page compressed by default. So if you look at the top there, compression type, page compressed. I only have the default file group because I created a very straightforward database here. But because I asked SQL Server to define it for me, it put it into the same file group as the main table. Now I'm using Management Studio here. You may be working on a Mac and decide that you want to use Azure Data Studio. Now these scripts are available on my GitHub profile, so I can show you that later, or you can find it through my blog. But if you don't have Management Studio and you still want to look at that information, you can run this query, which tells you exactly the same thing. Here is the schema, here is the object name. It doesn't have any data in it right now, and it uses page compression. So let's put some data in there. I'm just going to, I am going to put in one row. And because I'm a huge fan of Back to the Future, let's start with Lorraine Baines, who was Marty McFly's mother. Now, Lorraine Baines in 1950 odd would have not been making a huge amount of money, so I've put in here an annual salary of $2,500 a year. But this address, 1727 Bushnell Avenue, Hill Valley, California, and legal assistant. And in it goes, as you would expect, just like any insert into a regular table. So let's see what it looks like. Surprising no one, there's the valid from and valid to. Remember I said that there's no null values for the period to, so look what they've put there. They've put the maximum value for a date in SQL Server, which is 9999/12/31 at midnight. What else do you notice about this time right here? Who wants to shout out? I'll give you a clue. My clock says 8:41 p.m., but this says it's running at 2:40. It's in UTC, exactly. Why do you think that is? That's not a trick question. Why do you think that is? Because time zones suck. That's why. It's the bottom line. Why have the possibility of an audit trail that has 2 rows with 2 a.m. on a day and not know which version is a daylight savings, isn't it? Who knows, right? That's why. So what I'm pointing out here is that notice that the period columns are included in the select star. So when I do a select star, or if I use my SQL prompt from Redgate here, and it automatically completes, but the valid from and valid to columns are there when you do a select. Now, Lorraine gets married, and in the 1950s, she was told to change her name as well. So all we're going to do is we're going to update this row of employee ID 1 to go from Lorraine Baines to Lorraine McFly. Exactly what you'd expect to see. Let's see what it looks like. So if you're working along with these scripts, once you've got them to play with yourself, there's a couple of instructions here, and I'll explain that to you now. But we did a select star just like we did before, and as you'd expect, the row has been updated. Lorraine McFly is the new value, and the valid from has been updated as well. I was speaking for 2 minutes, and so that's 2 minutes later from the original time. So now what I'm going to do is paste the valid from value here. I copied that, and I'm going to paste it in here. And then I'm going to run a whole bunch of queries, and then I'm going to walk through and tell you exactly what they are. So just have a little bit of patience while I select all of these things, and then I'll explain what they all are. So if you recall from the slides, I said that depending on if you want to look at a point in time in history, you would write a specific kind of temporal select statement. And that's exactly what I'm showing you here. I'm doing a select, and then I'm just adding a column at the beginning of each different type of temporal query to demonstrate what is shown to you when you run them. But if you were to run this without this keyword at the top that I added, it would just show you the regular data as you'd expect it. So current means the current table. So if we scroll up here, the current is a regular select star. If we do all, that is going to show you the current table and whatever's in the history. So this does a union all, in fact, between the current table and the history table. In fact, I'm going to turn on the estimated query plan and show you that is doing a concatenation between the current and the history table. That's what you get when you do a system time all query, because you want to see everything, right? This is the magic here. We're doing a temporal query for system time all. So bring me back everything. If you want to see a specific point in time, what I've done here is I've created a date that was 1 millisecond before the change. That's why I needed to copy that value. So if I do that, if we have a look back here again, of course, I did the query plan, so I've messed up my entire output here. If we have as of 1 millisecond before the change to Lorraine McFly, we'll see here, this is what the database looked like before that change. This is why I say this is the killer feature. If you know what time something happened, you can go to the point in time directly before that and see what the data looked like. Now there's a couple of other options here, and this depends on the kind of queries that you're wanting to do. If you do a between includes the rows that changed at the start, between the start date and the change date. So if you want to see everything in the history as well as the upper bound of your system time query, it will bring back 2 rows in this case. It'll bring back everything. But if you only want to see the current and history on its own and to the point in time before the upper bound, then you would use from and to. So that's the main difference between from and to, and a between query is the system time between will include everything between these 2 dates, as well as the outer boundary, and a from and to will return everything from before the change. And then the contained in is exactly what it says on the tin. Show me all the rows that were contained in this date. And it works in a very similar way to the from to. Why you would want to use these is entirely up to you, or how you would want to use them, not why. How you would use them is entirely up to you. It depends on what you're looking to do, but these are the different types of query that are available to you as temporal queries. Do you have any questions that you wanted to ask about this, or can we just go on?
So this is effectively what slowly changing dimension type 2?
Kind of, yeah. I think that's a fair statement to make. And remember, as long as your history table contains the history, as long as you've set it up correctly, you can go back any point in time to go and see exactly what it looked like.
Got it. Thank you.
So now what we're going to do is, we're hardcore in this house. We're going to drop the database and recreate it. Why? Because I want to show you something cool. In this case, we're going to create a schema beforehand. Now, this is just a demo. Normally, when you create a schema, you want it to be in its own file group so that you can go and store the history in that file group. I'm bypassing that in the demo just to do a proof of concept here, but it's exactly the same thing. If you create your schema and you set it up to write to a separate file group, then you can create your, I'm just going to move this down a little. You can create your regular temporal table, and then you can go and point it to a table in that schema. And you've set up that schema to write to a different file group, so you can manage the storage slightly differently to the default. And that's all that we're going to do here. It's exactly the same as previous, except that we're specifying the name of the history table. And because we're specifying it, we can choose the schema that it resides in. Again, we're just going to go over here and refresh. And sure enough, it's going to be exactly the same, except that the history table name is the one that we specified, and it's in its own schema. Now, this is something that you can do in Management Studio by right-clicking, but I wanted to show you the metadata in SQL Server if you don't have access to Management Studio or you're using something like Azure Data Studio. Using the object property extension here, you can go and look at the temporal table type, and it'll tell you that the main table is type 2, and type 2 means a system version temporal table. And I'm doing a union all because there's two different types of metadata query that you can do here. So this tells you the exact same thing here for the first table. That's all well and good. Or you can compare this to the other way, which is just querying systables. And it'll tell you exactly the same information, just in a different way. There's a dbo.employee, which is a temporal table, and history.employee, which is a history table. So this is just a script to show you ways to query the metadata. So now we're going to do yet another example of dropping the database and recreating it so that we can specify the history table, but connect it after you've created it. Because the two examples that I've shown you so far are we create the current table and the history table at the same time. In this example, we're going to create the employee table on its own. Notice there's no valid from, valid to, or anything like that to replicate an existing environment where you've got your vendor application and you want to go and add temporal data to it, temporal history. So sure enough, we're just going to run that quickly, and I'm going to refresh this on the left here, sorry. And as you'd expect, because we haven't specified the history table, it's just a regular table. Primary key, everything else is exactly the same as before. It just doesn't have those valid columns or the history table attached. Now we're going to tell this table that we're adding a valid from and a valid to column. But the key here, and I'm going to make this bigger, is that we're going to hide these columns. So if you do a select star, you will not see them, but they are there. You can specify them in your select query, but for application support, if you're plugging into an existing application and you know that select star will break your queries, because even though we tell you not to use select star, we'll use it. So this is just a way to make sure that anybody who does do a select star will not get back a different data set to what they're expecting because temporal has been enabled. So that's what we're going to do here. We're going to modify this table and add 2 columns. You'll note that I've told it it's a temporal table, but I haven't connected it to a history table yet. So I could still truncate this table, just for the record. So the hidden keyword, as a note here, is to avoid breaking existing queries and applications for backward compatibility. And Microsoft's big about backward compatibility, so that's cool. And I'm just going to do a select star, even though it's commented out here, just to show you that there's nothing in here because we haven't inserted anything, but you'll notice those 2 columns that are definitely there, as you can see on the left, don't show up in a select query. Now we're going to turn on system versioning. Now, what I put in the comment there is that data consistency check is by default set to on. You don't want to turn on a history table and have data consistency turned off. I don't know why you would want to do that, but Microsoft gives you the option to shoot yourself in the foot. Please don't. I'm showing you data consistency check equals on there. It's not required because it's done by default. So what I'm doing here is I'm saying, hey, I want to take this existing table and I want to create a history table for it. And now if I right click on tables and refresh, you'll notice now that it is a temporal table and it has the history table attached. The main difference here is that those two period columns are hidden. So we're going to insert our Lorraine Baines row again, and we're going to do a select star, and it's going to be exactly as before, except that there are no period columns. Straightforward. Now what we're going to do is we're going to change Lorraine's name to McFly and see what the data looks like again. And notice here, I'm specifying the period columns directly, because if I do a select star, nothing's going to show up. And once again, I'm just going to copy the value here into the script to show you the different data types. And the reason I'm showing you this is to show that with the period column hidden, unless you specify it, which I'm going to do in the current query, if you don't specify it, it's not going to show up, even with the temporal queries. So that's something useful to know. All of these are exactly the same as before. It's just that you don't see the valid from and the valid to. Now let's delete that row and see what the data looks like. Sure enough, there's going to be nothing in there. Cool. But because I showed you that query plan before, where it does a union with the history table, it's just going to run that and bring back both rows. Because it's doing a union all, it's going to show whatever's in the current table first, and then show you everything in the history table. So that's why you've got your history table first, and then whatever's in your current table. That's why your history is. I'm talking through my hat. Sorry, guys. I deleted everything, so it's going to be everything that's showing in the history table. That's why it's in that order. So what we're seeing here with the system time all is everything that's in the history table, because there's nothing in the current table, of course. So sorry about that confusion. But because it's doing a union all, it's going to bring back everything that you see first will be in the current table, and that's empty. That's why it's bringing it back in that order. Got it. If you have permissions to query the history table directly, because SQL Server allows you to grant and deny permissions as you see fit. But if you have permission to query the history table, you can do it directly, and it'll bring back whatever you'd expect to see. Let's insert a whole bunch of rows. Remember, we deleted everything from that table, so there is nothing in there, just to confirm, but it's all in the history. So let's insert a whole bunch of new rows. Lorraine, George, Biff Cannon, Jennifer Parker, Marty McFly. Right? So I'm just going to insert those 5 rows, and then I'm going to do a select. It's only going to return 5 rows, but because we already had a value in here of employee ID 1 that was deleted, it starts the numbering on 2, and this is the new row for Lorraine that we've inserted. If we want to see that including the history, this is what I was talking about with the order. Because the current table is being union-alled with the history table, the current data is shown first, and then the history is shown second. That's what I was trying to say earlier. It's easier to see in this example.
Randolph?
Yes.
Quick question. So this is going to be, you will be able to answer the when and what, but how can you answer who? So the user that did it, and also you can run a delete, but you can also run an update without the where clause. So which operation caused that change?
Very good questions. And I will show you what temporal tables can do, and you will be able to answer the question yourself. But I don't have good news for you. So if you have permission to delete from this table, this is SQL prompt saying, hey, you don't have a where clause. Watch out. Not everybody's got SQL prompt installed, so I'm going to execute it anyway. And sure enough, all 5 rows are gone. If I go and look in the current table, everything's gone. If I go and look in the history table with the system time all query, that's all my data. It tells me when it happened, because if the valid to is a point in time in the past, that means it's been modified. So it tells me exactly when the change happened, but this doesn't tell me who. I'm logged in as SA, I could be using Active Directory. I could be using an app role. It doesn't say any of that. If you want to keep track of that, you would have to do it independently. So that's why I said it's not good news. You can keep track of it using store procedures. Let's say that you want to use store procedures for tracking who has access to your data layer. So you would do all data modifications through store procedures, and you would write that off somewhere. But temporal tables, as they exist in the product, do not keep track of who made the change. Great question, though, because it is.
Can you add a default of user as name?
You can, but if you're using app roles or if you're using something else, then it may not track it exactly as you'd expect it to. Or if you're running it as a different user. Yeah. You can do that, but that's something you have to do. And then you'd have to keep track of it in your current table. And that's where it's a good question.
And it's also, I don't see a way of identifying what caused the change, if that was an update or delete.
Correct. Now, the easiest way to do that is remember, this is a combination of the current and the history table. If I did not run that delete and I only did the update, then the valid to would be the year 9999. Does that make sense?
Yeah.
So remember right in the beginning, we inserted Lorraine Baines first, and then we modified to Lorraine McFly. And you'll notice that these two times are identical. Because when Lorraine Baines was modified to Lorraine McFly, that's the original row, then it was modified to that. That valid to becomes that valid from. And then at some point later, by 1 minute, that row was deleted. How do I know that that row was deleted? Because it's not showing up with a valid to in the future. So you can deduce whether it was an insert, whether it was an update or a delete, based on the validity of the two columns. That's why you need both. But for keeping track of who did the change, you'll have to roll something yourself. So I hope that answers the question of what kind of modification it was.
Yep, thank you.
So let's demonstrate your question, Steve. Can you truncate? No, you cannot. Truncate failed on temporal demo.dbo.employee because it is not a supported operation on system version tables. You cannot do it while system versioning is enabled. But, and of course the same is true of the history table, but if you, I've got a demo later. I won't get too far. I don't want to get too far away from this. Okay, if you're running along at home, you are going to have to run checkpoint a few times because of what SQL Server is doing in the background, and I'm trying to reduce the amount of stuff in the transaction log to show you. But I want to show you what's in the transaction log when you do a modification, as dangerous as changing a column to a different data type. So, got that? I'm going to run checkpoint 3 times in a row, and then I'm going to change the data type of this column from decimal 10.2 to money. Where's the warning to say the data type has changed? There was none. Let's have a look at the transaction log. There's my checkpoint, so we can ignore these. If you've never read a transaction log before, it's a little bit trepidatious, let's say, but fairly simple to follow once you understand what's going on. So we have our checkpoint that ran to clear the back of the transaction log. And then we have a transaction that starts that takes a whole bunch of locks. And then it's a data definition language change, DDL. So in other words, it says, hey, you're changing a column data type. And what we're doing is we're going to modify columns because we're changing a column data type. So it deletes an old one and adds a new one called, in this case, annual salary is the name of the column. And it goes and modifies the columns in the primary table, the current table, as well as the history table. Look at all that stuff that's happening, 63 rows of stuff happening when I did that single line of code. There was no warning here, because if we expand this out, the annual salary is now money. And if we look in the current table, annual salary is money. There was no warning or anything to say that that was happening. So let's do this again. I'm going to drop the annual salary column without any warning. Done. Here is the transaction log. There's the checkpoint that I ran to clear the previous history, and there's the delete. There's the delete. It's modifying the system tables underneath the covers to say, please delete that column. And if we do a refresh here, and we do a refresh here, that annual salary is gone. Gone, gone, gone. Which means that if you have the right permissions to do a DDL change, a data definition change on your database, the history is also removed. So you have to be careful about permissions with temporal tables. Let's go and have a look in the history just to make sure. Yeah, no annual salary. Gone, gone, gone. So what are the implications of these two changes that I showed you? The first one was modifying the column data type, and the second one was completely dropping the column altogether. Remember that marketing slide? Can this be used for forensic auditing on its own? No, it cannot. You need to track it in an auditing rule. Not even the default trace will keep a record of this because it's just a column modification. If you have permission to do that and you're not auditing these changes in a different way, Temporal will not rescue you. So if you're thinking of temporal tables, you have to keep this in mind. Let's do a demonstration of in-memory, because we might as well, right? So once again, we're going to drop the database and we're going to create a new database and we're going to use it. And off we go. And I'm just going to refresh everything on the side here. Refresh. So we should have nothing in the tables. That we do not. Create the schema. And what we're going to do here, because of the way that in-memory objects works, is you have to create a separate file group that contains the Delta files that are used by SQL Server for keeping track of memory optimized data. So on my C drive under this folder, I now have a location on the disk that is addressable by the file system called in-memory file. And inside that folder, it creates a whole bunch of files that are used by in-memory. By the way, once you convert your database to use in-memory, you cannot turn it off. If you want to turn off in-memory support and delete this file group, you have to export your entire database to a new database. Pretty cool, huh? So I'm just going to right-click here, refresh, and go into the properties. Files. There's the in-memory row, just to show that it is slightly different. It uses file stream data. It is the file group in memory. That was the name I gave it. And it has unlimited size because it's limited by, in this case, the amount of memory I have in my machine because I have developer edition. If I had standard edition, it would be limited to 32 gigs. Nothing exciting there, but I just wanted to show you that. Now we're going to use our database and we're going to look at the sysdata files, database files, because you may be using a different tool like Azure Data Studio and you won't see the file options necessarily the same way. It's exactly the same stuff I just showed you. There's the file stream, in memory, etc., etc. Now we're going to create a table called DBO employee. And because we're creating this as an in-memory table, the SQL to do that is slightly different. If you've never used in-memory objects before, the data structures are mapped to memory locations. It doesn't have to create a data file on disk and then copy that into the buffer pool. It's addressing memory directly. So it uses memory pointers. And to use memory pointers, you have to use a bucket. of hashes. That's what's happening here. You cannot create a clustered index in memory because you're not actually sorting the data, because memory is random access. There is no way to order data in memory because it could be anywhere in RAM. But because of pointers, you know exactly where the next page is or the next item is, so it just has a forwarding pointer and it's easy to find. But that's why we have a non-clustered index here. And because I am going to have fewer than 100 rows in this table, I've set my bucket count to 100. It just helps with distribution of memory for when you want to insert data. There's a lot to in-memory objects that I'm not going to be able to cover in this because we're not talking about that, but I do want to point that out if you've never used this before. Otherwise, for the sake of this demo, it is identical to what we had before. We have an identity column, which is a primary key, and it has the two date-time columns for valid from, valid to. The period for system time is still the same. The main difference here is that because it's an in-memory object, we have different directives here. That's the only difference to what I showed you before. And here, sure enough, here's your history table. Now, you remember when I created the tables before that it was pretty quick. I'm going to show you, it's going to take a little bit longer. It's hard to see in a remote demo, but I hope that you do notice it takes a little bit longer to create this. And the reason it takes a little bit longer is because it has to create the in-memory object, then it has to create the history table on disk, and an additional in-memory object for translating the data between the two tables. So you'll notice it took about, it says 1 second here, it took about 1.5 seconds to generate those three objects. But once you start inserting data, it's quick. This is why we love in-memory objects, because they are quick if you're inserting and selecting. So here's my 5 rows that I did before, Marty, Jennifer, Biff, etc. There's my 5 rows, and if we do a select star, it's going to look exactly the same as it did before. But notice, because there's no clustered index, if you don't specify an order by, it's going to return it in whatever order it gets it out of memory. That's the first thing you're going to notice here. I could very easily say, order my employee ID. And in fact, Microsoft's documentation says this across the board. If you want data in a specific order, you need an order by clause. End of story. So if we do it that way, then obviously it's going to be in the same order as before. But I wanted to point that out to you to show you that in-memory objects are random because of the way that random access memory works. Now what we're going to do is we're going to dump everything out of that table, and I get my SQL prompt warning. But when I run that, it's quick. It took less than a second. Okay, I'm going to pause here briefly and say how many folks are using read committed snapshot isolation? Shout out the answers because I can't see your faces or anything.
I maybe use it once.
I recommend it. I recommend turning on read committed snapshot isolation if you are using an OLTP type environment. For reporting style databases, for BI, for data warehousing, it's not as useful to you because you don't need to keep versions of data while you're doing inserts and deletes and selects because that's not the kind of workload that you're doing. But for OLTP, transactional processing, read committed snapshot isolation keeps a copy of committed data in TempDB so that if somebody tries to read that row while it's being modified, it doesn't block you. So readers don't block writers and writers don't block readers. That's very simple. That's a very simple explanation of the feature, but that's what it's for. But if you are using RSCI, read committed, read committed snapshot isolation. Sorry about the typo, folks. If you are using read committed snapshot isolation, you might get a problem if you have in-memory objects. Let's do a regular system time all, and look what happened. I got disconnected from my database. All I did was try and do a select query from my employee, which includes a look at the history table, and it disconnected me. So if you've got read committed snapshot isolation, you need to, it's horrible. It's dead, Jim. This is great. Crash, boom, bang. Isn't this great?
Of course, this is only happens in Management Studio. Azure Data Studio doesn't have that problem.
Do I want to cancel the query? Yes, I do. Is it going to cancel the query? No. Probably not. So guess how I figured this out?
There is a question if this is the same if you use SQL CMD.
Will I still get this problem? Maybe. The thing about SQL CMD, okay, this is going to be a little bit, how's my time? I'm doing okay for time. This is going to take a little bit of a off the beaten track here. If you use SQL CMD, the connection options, your set options, are different to Management Studio. Most applications and SQL CMD connect using the same options, but SSMS doesn't. So if you're doing some sort of query caching, which SQL Server does, the set options could cause you to generate a different query plan. So Erland Summerskog's blog post about fast and SSMS slow in the application applies here. So the answer is probably, but I don't know. You'll just have to test yourself. So what I'm going to do is run the query with snapshot, because that's needed for read committed snapshot isolation when dealing with temporal tables that are memory optimized. I've written that here. The error message will be a query that accesses memory optimized tables using the read committed isolation level cannot access. So in other words, if you have RCSI and you want to do a temporal query against an in-memory temporal table, you need the with snapshot. That's what that's saying. And notice that the order that this came back is also different, because when it wrote it off to the history, the way it changed it in memory before it wrote it off to the history table was different as well. But Steve, this should answer a question you had. This all happened at the same time, and there's nothing in the current table because the validity is in the past. So these are all deleted. So let's talk about archival of current and history table with a rolling window. There's stuff in books online that talks about you can break the connection, the system versioning between your history and your current table and just do partitioning. You can do delete and truncate. You can do some sort of custom thing. And on 2016, you would have to, because the retention policy isn't available in 2016. Excuse me. So this is something interesting about the documentation. If you do stop versioning temporarily as a prerequisite for doing table maintenance, Microsoft strongly recommends doing this inside of a transaction to keep data consistency. That makes sense. If you're going to truncate your history table, you want to make sure that it's all happening in a transaction, so that the beginning of your transaction is break the connection between your current and your history table, truncate the history, then reconnect. That makes sense, because you don't want something else to make a change to that table while you're cleaning up the history. Unfortunately, if you do it with a temporal table that is in memory, it doesn't work. You cannot do DDL inside user transactions with memory optimized tables. So here's another thing that you have to watch out about with in-memory. Remember, the first thing is the translation between disk and in-memory is a little bit expensive in terms of CPU. It is, if you're using read committed snapshot isolation, it can cause problems if you don't put the right with snapshot query hint. And then finally, if you're doing some sort of work that involves DDL, which is the changing of the structures, then you cannot do it in a transaction. So tread carefully if you're using temporal tables with in-memory. Obviously, if I take it out of the transaction, it works just fine. So I've actually put that in my notes. As we wrap up, I want to point out these things. This all works in Azure SQL Database. Temporal tables work on all tiers, basic, standard, and premium. It's basically like having SQL Server Standard Edition supporting temporal tables as well. The in-memory stuff requires premium tier because, you know, memory is expensive if you're running in the cloud. So here's my final demo, retention policy. This is going to be really, really quick. Firstly, you want to check to see if your retention policy is enabled for your database. By default, it is enabled for the system databases there, and by default, it's also enabled for my database. I need to make you aware of something though. If you do a point-in-time restore using a regular SQL Server restore command, and you say as at a certain point in time and you want to restore your database, it will turn off the history retention. Does anybody want to tell me why? I'll tell you. If you do a point-in-time recovery and you've got a retention period, you don't want that to suddenly start deleting data from your just restored database. You want to make sure that the database that you've just restored is going to have all the data that you expect to have in it. So if you have a retention period set, it will turn it off so that it doesn't delete data that you don't expect it to. To set a retention period, you do it when you create the table, or you can modify an existing table by first turning system versioning off, then setting the retention period and connecting back to the history table again. And sure enough, it's as simple as that. Now I have a 9-month retention period on my in-memory temporal table. If you want to check out the retention stuff, this is a query lifted straight out of Docs, Microsoft Docs, that tells you, is temporary history retention enabled on this table? Yes, it is. That's the name of the schema and the table name for the history information, and this is the period that it retains information for. And I do stand to be corrected, but I think it is only set in weeks and months. I don't think you can do days for retention period. And that's it. That is the end of my session, the end of my demos, the end of my slides. If you want to get hold of me, I mentioned up at the top that you can email me. That's my email address, r@indiolph.ca. And if you want to get hold of me on GitHub, if I do this correctly, GitHub Born SQL. You can get a copy of these scripts and these slides from my presentations folder. There's temporal tables and the script that you've just seen me right now, and a minimized version of the slides because you don't want to see all of those big images. The DeLorean, sorry. I'll just put it back there so that you can see it now. Thank you, everyone. If you have any questions, let me know now, or you can email me. And it was a pleasure speaking to you tonight. Thank you.
Thank you. That was a great session.
Hey, quick question, and I don't know if maybe you said something about this and I missed it. I think you did say that partition tables are supported, right?
The partition tables are supported, but if you create a temporal table on a partitioned table, the history will be stored in the primary file group.
My question is, I manage kind of archiving and stuff through switching partitions. It's all more logical. It's all in the primary file group. I don't care about the file groups necessarily, but I'm assuming that in that case, there is no change to history when I'm switching partitions, right? Because I'm not changing data. I'm just switching partitions. Okay.
Correct. Yeah, that's a good question. And remember, I also mentioned during the session that you can even do table partitioning on your history table if you want to, and you can switch those partitions in and out.
All right.
So
great. Thanks.
For example, one of the use cases for this would be if you're trying to take an existing archive that you have of history and you want to start using temporal tables and have that old archive available, you would put it all into a staging table, transform it to have the same schema as your current table, and then you would turn on the history connection, the system versioning, to point to that sanitized data.
Okay, so I'm just kind of sorry, I'm maybe thinking out loud, and I probably should stop. But
Please,
so if I
please.
have let's say I'm keeping data for 3 months in the primary table, and I do care about my history and my changes and whatever else. Once I call it my archived, I'm gonna move it off. I'm not gonna do any changes, so the history remains. The data is in another table, so then it all kind of makes sense.
Yeah.
I think that works. Okay, sorry, I just had to kind of work through that process.
That's a good question. Good question. Does anybody else have any questions? And it's okay if you don't. If you think of something later, you can always get a hold of me by email. I am on Twitter, but that's not a SQL Server account. It's not. It's really not. But you can ask me questions on Twitter if you want. I appreciate it. Again, if you have any questions, please email me, and have a good evening. Thank you.
Thank you, Randolph. Thank you for all the members joining Los Angeles Data Platform User Group. Thank you.
Thanks, everyone.
See you all.
Bye-bye.
Take care. Bye-bye.